In this video, we're going to go through the Section 2.3 activity and the more price, demand, revenue, and profit problem. So this is working on the same scenario that we worked on in the Section 2.1 activity. We have our company that makes digital cameras, and we have the following price demand function and corresponding revenue function. So remember from the last section, we have our price demand function here. That's going to give us a function that gives price as the output or the y coordinate. And to find our revenue, we multiply price times number of products. So we're using that price demand function for the price. And then we can distribute this x in here. So our first question is asking us to graph the revenue function. So we can do that. I'll bring that up right here. Here's my graph of the revenue function. One thing that I wanted to show you is that when you are using the graphing calculator on Desmos, if you click on this Show Keypad button, it brings up some options that you may need in order to make your graph. So in particular, something that might be helpful here is using the A squared key to bring up the squared. You can use this A with the B as the exponent key to type in other exponents. Some of these other things might be helpful later on, so I just wanted to show that to you now. Click the hide keypad to put it back down. So this is my graph of my revenue function, and I can click on the share graph button to put the link or the image into my notes for question 1. And for question 2, it says to find the value of x that will generate the maximum revenue. Click on the point on the graph to show the coordinates. So when I'm looking at my graph, I can see the maximum revenue is going to be the peak of the parabola. And if I click on that, I can see that it shows up as a gray point. And Desmos is really nice in that it gives you the coordinates of these important points very easily. All you have to do is click on them. So when I look at this, I can see that the coordinates here are 9.48. So remember, that's the number of cameras. And the maximum revenue is going to be $449.352 million. So my x coordinate here that generates the maximum revenue is 9.48 million cameras. And the maximum revenue is going to be the y coordinate of that point, which was $449.352 million. Okay, so now remember from earlier we had this cost function, and we can use the cost function and revenue function to write an equation for the profit function. So we did this before, so we'll just kind of go through it again just to refresh our memory. Profit is revenue minus costs. So it's going to be 94.8x minus 5x squared when I multiply that revenue function out, minus the cost function. I distribute this minus sign. And then I can combine like terms and put everything together. It's the same profit function that we found in the last activity. Negative 5x squared plus 75.1x minus 156. Okay. And then question 5 is asking me to add the cost and profit functions to the graph. So I have already done that. So I'll switch over to that graph. So as you can see here, I have my revenue function still is the purple parabola. My cost function is the red line, and then my profit function is the blue parabola. So I have all three of those on the same graph. So I can, again, paste the link or image into my notes for question 5, and then going on to question 6, it says find the value of x that will generate the maximum profit. Click on the point on the graph to show the coordinates. So now I'm looking at my profit function. I can see that the peak of this parabola is not going to be in the same point as the peak of the revenue parabola. It's going to happen a little bit to the left. So if I click on the blue graph, there it is. It shows up as a gray point, and I can click on the point to make it a darker point and see what the coordinates are. So my coordinates are 7.51, 126. So remember, X is number of products, Y is dollar amount, so 7.51. That's going to be 7.51 million cameras is where the maximum profit is going to be. And the maximum profit itself, the dollar amount, is $126 million. Question 8 says, what is the relationship between the intersection points of the graphs of R and C and the x-intercepts of P? So let's look at the graph here to see that. So we're looking at, this is the revenue and cost. This is where they intersect. So there's 2 points where they intersect. I can see it's these 2 points here. I'll turn this maximum profit point off to get it out of the way. So these 2 points are where revenue and cost are the same, because the purple is the revenue, the red is the cost. Where they are crossing is where they are equal. Now, if I look at my blue parabola, I can see that the x-intercepts of the blue parabola have the same x coordinates as those 2 points. And that should make sense because we know when profit equals 0, revenue equals costs. So those are the same points. So this is a visual image that shows that fact. Where revenue equals costs, profit is 0. So I will type that in here for number 8. They have the same x coordinates. So where profit is 0, revenue equals costs. And then question 9 says to use the graph to find the break-even points. So we remember break-even points means that revenue equals cost or profit equals 0. Obviously those are the same. And so the x-coordinates of those 2 points are 2.49 and 12.53. So if we make 2.49 million cameras, we break even. If we make 12.53 million cameras, we break even. If we make between those 2 amounts, then we get profit. And if we make less than 2.49, we are losing money, so negative profit. More than 12.53, we're also losing money. So for those, for number 9, I'll put those 2 values in, 2.49, comma 12.53. So on the homework, you're going to see a problem that's going to have some similar types of questions. You're going to want to make a graph on Desmos in order to find the points. So make a graph on Desmos, and then you can easily find the maximum profit, maximum revenue, and the break-even points.